in order to understand what's going on, and this is actually real research we do from the boat. I think you saw in the initial picture, we're on a sailing schooner. It's a very good, stable platform, and it's actually good enough for us to conduct real science from. So this is Emily, an oceanographer with a CTT machine. You drop that overboard down to a depth of about 200 meters, conductivity, temperature, and density, which is basically the temperature of the water, and also the salinity of the water. So that's what we're measuring. We do it by hand. We don't have all the winches and all the sexy stuff they have on research vessels, but we do manage to, by sheer physical hard work, actually get the kind of information we're at. And, this is Dr. Simon Boxall, one of the chief oceanographers from the National Oceanography Center. This is the kind of information we find. What you're looking at here is a cross-section of the Gulf Stream or the Norwegian current, and about 78, it's up near 79 north, so it's a long way north. Scale-wise, it's 200 meters deep. The top of that picture is the surface, the sea surface. So if you're with a satellite, the only measurements you'll get of the temperature of the ocean are those kind of quite cool areas right on top of the sea surface. The whole river is underground. The whole ocean current is actually below the surface of the sea. And if you can see that from the bottom, that is 250 kilometers, about 170 miles across. So the size of this ocean that is under the water is, it's the size of about 6 Amazons. It is a colossal river. And Simon calculated the amount of energy needed to generate the temperature that's in this river would take something like 100,000 power stations. It's a colossal movement of heat around the planet. And it's the stability of these kind of major systems that we've been gauging and looking at. To do this temperature, what we had to do is stop the boat pretty much I think we did it about every 6 hours, and actually put the probe down that you saw, and then we carried on with the boat. And, we just carried on that process all the way across about sort of 1,000 miles of sea. It was hard work. And I'm just, if you think that it's very nice going up to the Arctic, I'm just going to show you a small piece of film.
Oh, there's a nice one! It's a salty sea this morning.
Sound on that, please.
Thursday, September 27th. 3 days from Greenland. If you're in dire straits, let me know. Install microwave oven, custom kitchen delivery. Got the movies, refrigerator. Got the TV.
Okay. It is quite extraordinary that that was after 6 days of sailing. It really was quite brutal some of the time, and especially when you can imagine trying to stop the boat in those kind of weathers to kind of actually do the measurements we needed to do. The other thing is, that 6 days, we're all getting a bit stir crazy, and we're just about thinking we've only got 2 days to go and we can get into Scoresby, which we were heading for on East Greenland. So there's a kind of a sort of madness about the crew at the time. We thought we were doing fine, but actually what happened was we got caught in an incredible ice flow as we were coming into the East Greenland coast. Now, it shouldn't have been there. The ice flow itself should have been somehow about 200 or 300 miles further north. So why it was there completely confused us. It also meant that we sailed around in a complete circle one day and ended up in the same place, and then had to fight through a storm. I mean, it was really gross, and it took us about another 3.5, 4 days to get into the east coast of Greenland, much further south than where we wanted to be. It was quite extreme. What we found out when we returned is we actually looked up and figured out why was the ice there, and this is the piece of information we got. So if you can imagine that the kind of the pink line is where the summer ice should be at the North Pole in the summer. So that is the extent of the ice. What happened in '07 is it retreated 25%. So 25% of the ice at the North Pole just disappeared in 1 year and that year. It again repeated itself in '08. So that all of the mathematical modeling that the climate scientists were doing, saying, oh, maybe there won't be any summer ice at the North Pole in sort of, 2080 or something like that. They're now revising those numbers, and it could be that in 6-10 years, there will be no summer ice at the North Pole. I mean, this is a major, major drastic change, and it's really quite frightening. And it means that one of the major stability sort of governors of the planet, one of those big natural forces, is actually going out of kilter. And it's sort of unimaginable when you imagine the scale of the size of what we're dealing with, is that actually human activity can cause something of that magnitude. And it's sort of only happened in the last sort of 200 years since the Industrial Revolution, when we've been pumping out this greenhouse gas, carbon dioxide, into the atmosphere, and methane and various other ones, that we've actually created this problem. But it is extraordinary that our activity has created a problem on that scale. So, this is something that the clock is running down on. We've actually got to kind of engage with. And how do you engage with it? How do you manufacture it? How do you change human activity in a way that encompasses this kind of quite global challenge? And it's exciting. At the same time, it's threatening, and it has all the kind of the tension of creativity based in it. We arrive there, and what is extraordinary about the Arctic itself is just how unbelievably beautiful it is. The engagement with the beauty of just seeing an iceberg, or the northern lights as we're sailing into Greenland. You suddenly, this very magical place just kind of unwraps itself and offers it to you, and it's a really inspiring place for the artists to get involved in. What the artists do, and this is what is interesting, the scientific information I've just given you is incredibly abstract, it's global in scale, it's actually difficult to conceptualize in your head. But what the artists do is turn that into a personal narrative, almost a human scale. I was there, I reacted in this particular way. So the story, the narrative, becomes something that is human that we can all engage with and get to understand. I'm just going to show you, this is from the film that we did for the BBC. This is Ian McEwan, the novelist, talking. We're going to need a bit more sound, quite a lot more sound on this if we can, please, if we can run it. It's quite important we listen to the words of Ian.
I thought maybe I should approach this as a dilemma, really, about long-term interests. We've got ourselves in a situation where we are having to address the needs of people unborn, not our own children, maybe not even our children's children, but generations after that. Even the most idealistic of thinkers and actors on the world stage in the past have really addressed themselves to problems in the present. To bear the weight of the future in this way is both interesting and difficult, and runs probably counter to our nature. And so I was wondering if there was some way into this subject artistically that would look at it sympathetically from the point of view of that impulse in us that refuses to do this. It's strange to say this, get on the polluter's side, as it were. I mean, that includes all of us. The consumer, the polluter, the despoiler. And we're all sort of weak and lazy and stupid in this respect.
It's very interesting, you can't write a contract in this sense with an artist. You can't say, well, I'm going to take you up to the Arctic and you're going to write your next novel about climate change. That is not the artistic process. What you can say is, I'm going to get you, please engage with the scientists, listen to what they're saying, be inspired by the place, be inspired by other members of the crew, and hopefully you will be inspired to write a next novel.